Okay, so we're going to look at photosynthesis. Here's the equation for photosynthesis. Now this is just in words. You're going to need to know it in symbols. But you should already know it in symbols. Because it's just the reverse of what? Okay, tell me a little bit more. What kind of respiration? Aerobic. Okay? It's the opposite of aerobic respiration. So in symbols, to do photosynthesis, you got to have some light. It doesn't have to be sunlight. It could be light from a bulb, right? You got to have some light. You got to have some CO2. You also have to have some water. Now, in the cell respiration equation, there was no light in the cell respiration equation, but there was what kind of energy? ATP. These three things were all what in the cell respiration equation? Products. They are the reactants for photosynthesis. Light, energy, carbon dioxide, water. These are the things a plant, an organism that does photosynthesis, has to have to be able to do photosynthesis. And then the products. The reason for doing photosynthesis is to make what? Sugar, glucose, food. And I'm going to write it as just C6H12O6. And then a waste product for the plants is oxygen gas, O2. And remember the balancing. It ought to be easy to remember how to balance it. It's 6, 6, 6. That ought to be pretty easy, right? 6, 6, 6. Should be pretty easy to remember. Okay? Photosynthesis is the beast. You ought to remember that. Regardless, a couple of other important points. And this is, first of all, a misconception. Do plants need oxygen gas?
Yes.
Yes, because plants, like you, have to be able to do what? Cellular respiration, aerobic cellular respiration. They need oxygen, but they make more of it than they need. Okay? So they give off extra oxygen, but they do use some oxygen. They do cell respiration, just like you. They have to have oxygen in order to make ATP. They need ATP just like you do. They don't need as much as you do, but they need some. They need some ATP. So this equation, you got to know it. Occasionally, and I think your book may show this. Occasionally, instead of writing C6H12O6, in some books, you'll see the sugar written like that, CH2O. It's just reduced, right? You take out a 6, factor out a 6. This is like the simplest formula for a sugar. In a sugar, for every one carbon, there's going to be 2 hydrogens and 1 oxygen. That's like the reduced form. What's the word for that in chemistry? For like the most reduced formula for something. It's called the empirical formula. Yep, the empirical formula. That's basically what we've got here. This is the empirical formula for a carbohydrate. Just recognize that. If you see that, say, hey, that's sugar. Now, in terms of photosynthesis, we all know plants can do photosynthesis. Are there other things that can do photosynthesis besides plants?
If we do
Say again? We? No. What other than plants?
Cyanobacteria.
Cyanobacteria. There are some bacteria that can do photosynthesis, and we usually call those cyanobacteria. So we got plants, we got cyanobacteria. There's one other kind of thing that can do photosynthesis. What is it? Not fungus. No, not fungus. Euglenids are right. They're in what broad group? Protists. Yeah, let's be a little bit more specific. What kind of protist? Plant-like protists, which are sometimes called algae. Okay? Algae. Plant-like protists, algae. So those are the kinds of things that can do photosynthesis. Plants, algae, and cyanobacteria. And because they can do photosynthesis, what's a word we could use to describe all three of these things? Okay, autotrophs. Let's be a little bit more specific. Photoautotrophs. Meaning that they use light to make their own food.
Are there other autotrophs besides photo?
There are. And that's like 2 slides from now, so give me just a second and I'll get there. Now, let's break this word up for just a minute. Photoautotroph. Photo obviously means light. Auto means what?
Itself.
Self. And troph, what does that mean?
Food.
Means energy. Now, that's kind of a misnomer. It's not really true, because literally that word means they use light to make their own energy, right? Well, we know you can't do what with energy? You can't make it. They don't make any energy. They just take light energy and store it in what? In a chemical. And I'm going to come back to that in just a second. That's one word we might use to describe things that can do photosynthesis, photoautotrophs. What's another word we might use to describe things that do photosynthesis? Because of where they're at in the food chain, because they're at the bottom. Producers. We might call them primary producers if they're at the very bottom of the food chain, right? They're the things that initially make the first kind of food. They take the sunlight, convert it into food producers. So just know those terms. Since we're talking, let's go ahead and define photosynthesis. Simple definition. It's one that you probably heard something like since third grade. Photosynthesis is when an organism takes a light energy and converts it into chemical energy in the form of, usually, glucose. So let's say it's a conversion of light energy to chemical energy, usually in the form of this right here, glucose. Light energy to chemical energy in the form of glucose. That's the definition for photosynthesis. Any questions on any of that stuff? In the form of glucose. Yep.
Can you repeat that one more?
Yep, it's when an organism converts light energy to chemical energy in the form of glucose. Now, most of this stuff we just talked about, but let's go through it. All the energy on Earth, with a couple of exceptions, comes from the sun. All the energy that's important in biology comes from the sun, in one way or another. When you eat a steak, you're eating sunlight. Because, yeah, sunlight's yummy. Because that cow ate grass, and that grass absorbed what? Light to become grass in the first place. So all the energy on Earth, every calorie that you take in came from the sun. All, because calories are just a unit for measuring what? What do calories measure? Energy. They measure energy, okay? So all that energy in one way or another came from the sun. Autotrophs are things that can take that sunlight and use it directly. Or, not all autotrophs can do photosynthesis. And this was Austin's question. If you remember back to the first or second week of class, we talked a little bit about this. You had a little online assignment you had to do with that, chemosynthesis. Chemosynthesis is the process of taking not light, but taking energy from what? From chemicals. Usually inorganic chemicals.
Wait, what was it again?
I'm getting there. Just one second. Usually taking inorganic chemicals, energy from inorganic chemicals. What does inorganic mean?
It doesn't have carbon.
Not carbon-based. Usually, what are these chemicals based on that they use to do chemosynthesis?
Sulfur.
Sulfur. They're usually sulfur-based chemicals. And where are these chemicals, where does this normally happen, chemosynthesis?
Thermal events.
Deep, deep in the ocean, where there is very little, if no what? Light. So these are the things down there deep in the ocean. They take energy from inorganic sulfur-based chemicals and use that energy to make what? Food, sugar. So it's much like photosynthesis. It's just there is no photo. There's no light. So instead of using energy from light, they use energy from chemicals. So it's the process of taking energy from inorganic sulfur-based chemicals and using that energy to make sugar, to make food. So it's a lot like photosynthesis. All right, we know that everything that's not an autotroph is a heterotroph, has to eat. And literally, what does that word heterotroph mean? Hetero means?
These other.
No, what's hetero mean? It's like heterosexual, guys. What does that mean?
Different.
Opposite. Different. Okay? You have to get your energy, troph means energy, have to get your energy from a different place than yourself. You have to eat. There's different words for different kinds of heterotrophs. Obviously, an herbivore eats plants. Carnivores eat meat. And omnivores eat both. Most people, when they hear the word carnivore, what three animals do they think about? Lions and tigers and bears. Oh my, right? But bears are not right here, right?
They eat berries.
Bears mostly eat plant stuff, berries, roots. They'll eat meat occasionally, but most of the time they're more herbivore than they are carnivores. They're omnivores, like us. Maybe the only exception to that, polar bears. Okay, there's not much plant stuff for them to eat where they live, right? They eat most of the meat. They eat seals and people and quails and whatever else they can find. Polar bears.
I read somewhere that polar bears aren't even really classified as bears, more raccoons. Pandas. So that's weird.
Pandas, I think, are more related to other animals than bears. But polar bears, as far as I know, polar bears are bears because here's how I know that. Up north, polar bears in the wild will crossbreed with what else?
Like bears.
And grizzly bears. So they're pretty closely related. Otherwise, they couldn't interbreed like that. They weren't really close.
Wouldn't they be, wouldn't the baby be sterile?
You know, I don't know. A lot of times that kind of thing is, but it depends on how closely related they are. Like a horse and a donkey can breed, but their baby, the mule, is sterile. But there are other animals that are different but kind of close that can reproduce and their babies are still fertile. I'm not sure about the polar bear and the grizzly. I don't know. One other word that I want to throw in here that we've talked about, another kind of heterotroph is a saprophyte, or sapro. Those are decomposers, right? The things that eat dead things. And usually, what kind of organisms do we apply that word to? Fungus. Because they're like plants, they feed on dead things. They look like plants, but they feed on dead things. Saprophytes. All right, I'm going to ask you guys a question that I saw in some kind of video. These researchers were asking Harvard graduates on the day of graduation. They all had on their caps and gowns at Harvard. And they went around asking them this question. And they were asking science majors this question. And about half of them, or maybe more, missed the question completely. Harvard graduates. We're playing a new game show here today. Are you smarter than a Harvard graduate? Okay? Here's our game show. It's multiple choice. Listen to the question. Everybody's got to hold up their hand and vote. It's a multiple choice question. You got to vote. What they had is they had a big block of like firewood at Harvard's graduation. Just dry firewood. And the question was, here's this piece of wood. Most of what this piece of wood is now made out of, most of the weight of this piece of wood, where did it come from? And the choices were this. The choices were from the ground, from the air, or from water. Now remember, it's a dry piece of firewood. Again, the question is, you got a dry piece of firewood. Where did most of the stuff in that firewood, most of the atoms, most of the molecules, where did those originally come from? Did they come from the ground, from the air, or from water? So let's take a vote. How many and let's start at the bottom and work our way up. How many of you think most of that piece of firewood came from the water? So you got to vote. Hold up your hand.
That's what you're voting for?
Yeah, hold up your hand for the one you're voting for. No, I'm not voting. I know what the answer is. 1, 2, 3, 4, 5. All right, we got 13 votes for water. How many vote for air? Don't vote twice. 1, 2, 3, 4. Got 7 votes for air. How many vote for the ground? Just Janae. Okay. Well, we have 7 people in here who are smarter than a Harvard graduate. Okay. Now let's think. Let's think back to that equation.
Water vapors there.
Think for a second. But if you have the plants, don't get it. Back to our equation for a second. A piece of wood is mostly made out of what chemical? Cellulose. That's in the cell wall of plants, right? Cellulose. That's what wood mostly is. What's cellulose a polymer of? Cellulose is a polysaccharide made of what monosaccharide?
Carbohydrate.
What glucose?
Take away.
Beta.
Yeah,
Beta glucose. Hard to digest, okay? Glucose came from photosynthesis, right? If you think back to that equation for photosynthesis, we know the reactants to make that glucose are carbon dioxide and water. So two choices could have been right. Water, air. Those lead to C6H12O6. But in this C6H12O6, the C obviously comes from the carbon, right? Where's the O's come from?
Water.
These O's, okay? These are the O's that end up over here. Where do these O's go? Those are the O's you're breathing right now. Those are the O's the plant is giving off as oxygen gas. The only part of this water that ends up in the cellulose is which part? The hydrogens. And what do we know about the weight of hydrogens? They're number one on the periodic table, right? They're the lightest element out there. So most of a plant used to be gas. It used to be carbon dioxide. Plants are made out of gas. Carbon dioxide. Does gas have weight? Yeah. How many of you picked up one of those tanks, cylinders that you use on the gas grill?
They're heavy.
Well, when they're empty, they're not very heavy. But when they're full, these things are heavy. If you were to take one of those full gas cylinders, don't do this inside. Don't try this at home. Full gas cylinder, put it on a scale, like a bathroom scale. Open the valve. Start letting the gas out. You're going to see very quickly what's happening to the weight. It's dropping quickly. Gas has weight, and that weight makes up trees. It makes up plants. The weight of a tree used to be the weight of carbon dioxide mostly. Yeah.
The tank we have to use, the CO2 to fill our cylinders every morning, it's when we have to get it refilled, taking it back from the truck is.
Yeah, well, they're heavy, no doubt. Gas has weight. Now, let's go back a little bit in history. Talk about a guy named von Helmont. Back in the day, if I'd asked a person before we understood photosynthesis, where did most of the weight of that tree come from? What would most people back 100 years ago have said? The ground. They were thinking the plants were sucking a lot of stuff out of the ground. Now, the plants are sucking a lot of water out of the ground. That's important. That water, though, for the most part, doesn't become part of the plant. The oxygen part of the water is just released by the plant. But people thought that all that stuff that they were making the tree out of was coming out of the ground. What's the other thing, other than water, that plants take out of the ground? Other than water, what do plants need from the ground? Nutrients, minerals. That's no different than you taking away. Vitamin tablet. Okay? A plant taking stuff out of the ground is no different than you popping a vitamin tablet. Why did plants need minerals and vitamins?
To support the
For their enzymes to work. The same reason you need them. Vitamins are considered to be what? Coenzymes. They're organic. And minerals are considered to be cofactors. Regardless, you need those two things for certain enzymes to work. Plants are no different than you in that regard. We talked about this the other day, that if a woman